On April 4th, 2023, Virgin Media, a very big UK ISP, experienced some outages, and as a result, two things happened. Customers using that ISP as their internet provider could no longer access the internet. What happened really is their packets can leave the ISP and go to their destination because the route did exist, but when the server on the other end tries to reply back, setting the destination as the Virgin Media IP address, whoever the customer is, those incoming packet could not get in. So that was the first thing. So if you're a customer of Virgin Media, you just lost the internet. That was the clients. So the other thing is servers hosted on Virgin Media ISP, such as their DNS servers. All their DNS servers are in that ISP, in that autonomous system. If you're outside the ISP, like in the US or anywhere in the world, and trying to get to those, try to connect, those connections will fail. And that's because the authoritative name servers live there in that ISP. Because of that, any DNS resolution to virginmedia.com or even their website that tells like, hey, there is an outage or not, the status website, that site was down. And the reason is because when you try to resolve virginmedia.com, you need to go to the authoritative name server, and that name server located in the Virgin Media ISP autonomous system, and any IP address there is basically unreachable. And the reason is this beautiful thing that the internet runs on. It's called Border Gateway Protocol, BGP. Cloudflare has a nice write-up. Let's read through it and discuss. All right, so this comes from Cloudflare. Let's read through this and discuss and try to understand this a little bit more. And we're going to explain autonomous systems and border gateway protocol in details as we go through this. Right? It comes from David Belson. Just after midnight UTC on April 4th, subscribers to UK ISP Virgin Media AS5089 began experiencing an internet outage, with subscriber complaints multiplying rapidly on platforms including Twitter and Reddit. Cloudflare Radar data shows Virgin Media traffic dropping to near zero around 30 minutes right after midnight UTC, as seen below in the graph. Connectivity showed some signs of recovery around 2 a.m. 30, but fell again an hour later. Further nominal recovery was seen around 4:45 in the morning, UTC again, before again experiencing another complete outage between 5:45 and 6:45, after which traffic began to recover, reaching expected levels up until 7:30 UTC. Here's an interesting thing. Let's read through this part. At the time of the outages, www.virginmedia.com, which includes the provider's status page, was unavailable. As seen in the figure below, a DNS lookup for the host name resulted in serve fail, indicating that lookup failed to return a response. This is because the authoritative name servers for virginmedia.com are listed as NS124 virginmedia.net, and those name servers are all hosted within Virgin Media Autonomous System AS5089, and thus are not accessible during the outage. And we're gonna learn why they are not accessible. What Cloudflare did is like, okay, let's look at the PGP activity. So what is PGP? So you can think of PGP as it's a collection of IP addresses, like not just actual IP addresses prefixes, because it's very hard to enumerate all the IP addresses. So you say, I don't know, 1.7.7/24, which means 1.7.7, 0, 1.7.7.1, and so on until 1.7.7.7.254, right? So all of these permutation and so on. So you'll have all these prefixes. So if I'm a customer to Virgin Media, then my router will get a public IP address belonging to Virgin Media's one of these pool of IP prefixes. That allows me to get exposed to the internet, right? So that's how it works. So I don't have to be an actual server for someone reaching out. Even if I am a client, I still need a public IP address, right? Yes, my laptop or my other devices can still have a private IP address, and this creates a private network to my router, but my router eventually has another WAN port, and that WAN port has the actual public IP address. So this way I can connect to the internet. So any packet I send, the source IP becomes this IP address, and that IP address belongs to my ISP. Like it's leads to me, right? So the question becomes now, I don't think we need to, let's go with this, yeah. So the question becomes now, it's like, okay, I have now about a list of IP addresses in this pool of this autonomous system. But this is not enough, right? Because how does these other groups of autonomous system or other ISPs, how do they know of each other? So you're gonna meet the protocol that's called Border Gateway Protocol. Given these IP addresses, right, each ISP establish a neighboring relationship with other ISPs. They must talk to each other, you know, and this is a well-known relationship. So every ISP, it creates a relationship to its neighboring ISP. That's it. So it's just a relationship. So these public routers talk to each other. So I say autonomous system number 1 talks to autonomous system number 7, and 7 talks to 3, and 3 talks to 4, and 4 might be connecting to 12 and 13 at the same time. And you create almost like a graph, right? And that's it. But still, that is not enough. That's just the connectivity of this autonomous system. The other beautiful part about BGP is actually the advertisement. It says, okay, now we're connected. All what the ISP does in its protocol says, all right, I have these list of IP prefixes, IP addresses. All what you do is just talk to your neighbor. It says, hey, here are all my IP addresses, and you can reach those through me. That's all what it does. Right? So what the other ISP does, or the autonomous system, will receive those collection of IP addresses. Okay, I can reach all of these IP addresses through this autonomous system. And let's give it a name, right? So autonomous system 1, AS1, right? So AS1 gives you a collection of IP addresses, right? It says, all right, you can reach these IP addresses through me, AS1. So AS2 received them and says, all right, I need to talk to my neighbors. Say, okay, I just received an update statement, right? An update message for BGP, and says, all right, I received all these IP addresses, and you can get to those through AS1. But to talk to my neighbor as an AS2, my neighbor is AS3, you will basically send the same payload, says, all right, all these IP addresses, you can reach through those IP addresses through me, AS2, and then AS1. So it appends or prepends itself to the update message and propagates it. And then AS3 does the same thing to its neighbors, right? It adds itself. So what you get is a bunch of attributes in these messages in the BGP. And these messages will have this AS path, which is autonomous system path. So to get to any of these IP addresses, someone down the line, some ISP 19 will say, all right, to get to this IP address of Virgin Media, you have to go through AS19, AS3, 2, and then 1 to get to it, right? And every hop will have a next hop attribute to tell you exactly which router to talk to. Remember, we talked about these public edge routers, they talk to each other, these neighboring router. Those next hop, that's another attribute in the BGP. And based on that, it is a very complex protocol, because not only the cost of the length of the AS path is taken into place, but also other attributes. Like, okay, maybe what you'll find out is the same IP address, you're gonna have multiple paths to get to it, right? Always, right? Because it's a graph and things are connected to each other. So routers can get a choice. I can go through the longer path. I can go to the shorter path. You might say shorter path is always faster, right? Shorter hops to ISP. No, really, because you have no idea how many internal hops in the ISP you have to do to get to your destination, right? So that's not always the case. That's why BGP is so versatile. You can use the length of the AS path. You can use the next hop. You can say, all right, this chain contains an ISP that I don't really have good relation with as an ISP in that country. I don't want to route my traffic to that country for some reason, right? So you can choose other ISPs. So politics come into the picture and things like that, right? So it's a very interesting protocol with a set of policies that other protocols don't get you. Now we understand BGP, right? So we can update our IPs so that literally the whole internet knows of our existence, but we can also withdraw. So let's say this IP addresses, list of IP addresses is no longer valid. You can send a withdraw message to say, okay, I'm no longer reachable to this IP addresses. Please remove it from your entry, and it will be removed. And I'll make another video detailing BGP, but that's basically in a nutshell how it works. So let's get back to that. So now we understand BGP in a nutshell. There's an update, which is like an announcement, and there is the withdrawal. What happened with Mr. Virgin Media? So right after midnight, we see a huge spike, like around 1K withdrawals right after midnight. It's like, what is happening? These withdrawals are coming from that Virgin Media ISP saying, hey, they withdraw essentially almost all their IP addresses for some reason, right? Why? Nobody knows. This could be literally things going down in their network, and those IP addresses are no longer reachable, and as a result they say, oh, the public edge routers says, oh, I can't see these IPs, might as well just let me just withdraw these, since I'm not reachable. I can't reach them, so why should I advertise them, right? So that could happen, right? And then as a result, they sent a huge, massive set of withdrawal to all their IPs, right? And after a while, of course, the moment you announce the withdrawal, a few minutes later, the whole internet will learn about this withdrawal, and IP addresses that belong to this list will no longer be routable, right? Because all the routers and all the other ISPs at some point know that to route to these IP addresses, they have to go through this path and this path and this path. All these are gone. All these paths are gone because they were withdrawn for some reason, right? That's what happened to Facebook a few years ago as well. They just went dark. Basically, they just stopped announcing the Facebook ISP. Facebook also have an autonomous system, by the way. What happened here is after a while, they actually realized the mistake and started announcing some of those IPs. IP prefixes, not all of them, just some of them. So internet came back again, right? And then after that, they removed it again. It's like as someone is like unplugging and plugging something back. It's like, oh, yeah, what do we do? Oh yeah, let's put this in rice. Okay, let's turn off this and turn it back on. And let's restart this machine. Let's flip 3 times and do jumping jacks. Yeah, it's just, that's what's happening. Beep, 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 beep. Remove cards, put in a fiber card here, remove card. I'm just making things up. I have no idea what happened. But this is exactly, it's funny looking at this graph, right? It just, you see announcement, and then right after that, withdrawal. Right after that, another announcement. Right after that, a bunch of withdrawal. Maybe they were experimenting with new IP addresses and changing the IP addresses. Who knows? But that's what's happening. Every time they withdraw, internet goes down. Every time they announce, internet comes back up. The main problem is, and I like to kind of to talk more about this is so what I like to talk about is actually what can you do when this happen, right? If I no longer, as Virgin Media, I no longer advertise any of my IP prefixes. So IP addresses that belong to me are no longer reachable. That is different. I still can technically reach the whole internet. I can still go to Google, right? So if one of my customers want to send to connect to google.com, which is an American website, right? The first thing we can do is gonna do a DNS. That DNS is gonna probably use Google's DNS. It depends also, right? If the DNS uses some recursor that exists in that autonomous system that is down, that won't work, right? But if it's outside, then that packet will go, right? But what will happen is that DNS query will reach that google.com resolver, let's say, and will try to return back with the response, the IP address of google.com, right? And you're gonna get back an IP address, right? But the destination is what? The destination is actually Virgin Media's public IP address, right? We're trying to send an IP packet back. But guess what? The first line of defense, which is, I suppose, Google in this case, right? Autonomous system will say, wait a minute, what is this IP address? I'm looking through my route and I see no entry. There is no way I can forward this IP packet. It doesn't seem to exist in my table. So it gets dropped because the router previously might have had entry that, oh, this particular IP address of Virgin Media, again, 1777, for example, just making things up. Oh, it used to be autonomous system 17, 19, then 3, then 2, and then whatever, their autonomous system, right? 5089, right? Oh, you can get there. Or I can get through it through 13, 12, 5001, and then 5089. I can get it through this, right? All of these paths are gone, right? And as a result, all these paths, they used to have, of course, a next hop, which is literally a next hop is basically which router to forward this next, right? And this must be basically directly connected to my ISP, right? The next hop, right? If I don't see that next hop, I can't send anything. That's why the next hop and the AS path, I suppose, is the most two important PGP attributes, as far as I know, right? So yeah, so if you send, you can deliver your packets, sure, but you don't get responses. As a result, might as well the internet's not working. So I wonder what happened if you even if you try to establish a TCP connection, you can't. Even, let's say you got the IP address, let's say you have it cached in your local machine. Even then, you would send a SYN, but you won't get the SYN-ACK. And as a result, the server will never get your ACK back and will never finish the TCP connection, right? So internet, basically, that's dead on arrival. You can't do anything, right? And flip the equation where you're no longer a customer in Virgin Media. Someone outside, me, right, in California. I'm trying to access a server or a service in Virgin Media, an IP address there, right? And in that case, I would put my IP packet destination there. That won't reach, right? So that's just dead on arrival. My ISP will never find that IP prefix in their table because it has been withdrawn. And because it has been withdrawn, it doesn't know where to send it next, right? If it was there, then it will look it up the table and say, all right, this IP address, I see I can take through this path, through this path, through this path. If it's this path, I go to this next hop. Let's say this is my neighboring ISP, and or this path, this is my other neighbor, or this path, this is my next hop, other third neighbor, right? I can do any of these. So I know I need to get to this IP address, but that IP packet, the IP address will be there, but I still really need to send it to this next hop, or this next hop, or this next hop. Let's say it's H, right? That's a different, right? So this is exactly what happens. So what do we do in this case? Do we actually change the destination IP address to be the next hub, which is that my router? No. We can't, right? Because we're going to lose that. So what happened is this IP packet is slid into the data link, and the destination MAC address, right, in this case, becomes that next hop, right? So we're going to do an ARP. So these two routers is literally in the same network, right? Between me as an ISP, that router, and that destination other router, then my neighbor. So I must be in the same network in this case. It's as if it is almost like sending, going to google.com while you're on your laptop on a Wi-Fi. So technically, this IP packet going to google.com IP address, let's say 8888, is not, it's need to get to Google, but your next hop is technically your gateway, which is router. So you can't change the google.com to be the to be your router. What you change it to is, you don't really change it at all, right? You put that IP address into a MAC frame, and the destination MAC, right, is the MAC address of the router. You do an ARP for your router's gateway IP address, you get that MAC, and then you put it there, and then you just ship that IP packet as is to the router. The router will pick it up, and then in this case, it will find the destination and say, oh, that's not the frame in the data link is destined to me, but the IP destination is actually somewhere else, right? And that is where it just goes through the same journey. It's so beautiful, simple yet complex, learning about all this stuff. I love this stuff. I love to kind of ask myself questions and try to explore, right? And getting to the bottom of all this stuff. Hope you enjoy this episode. See you in the next one.